Hi everyone, I hope you all are doing well. Uh, First of all, I would like to thank um, uh, Medcomnet chair and all organizer for giving us a chance to present our article in this conference. Um, my name is Furkan Rustom, and my co-authors are Ali Raza, Imran Ashraf, and Ankat Delia Jurkat. Um, the title of my article and my presentation is Deep Ensemble-based Efficient Framework for Network Attack Detection. And I'm going to talk in this study on several points: introduction, literature review, proposed methodology, results and discussion section, and conclusion, limitation, and future work. These all are things that you can buy from my article. Uh, first of all, First of all, I will talk on introduction. And in introductions, I want to mention that as my topic name is network attack detection, and I'm working on local area network security. Um, these local area network security, these local area networks, we are using many kind of activity like in business, education, and many more things. And these local area networks are become more critical when we are connecting them to internet and to communicate with others. Attackers can use that kind of internet and can control on your even on your local network. And it become very critical for you to get back that kind of network. So in this regard, different researchers are working on network security system to improve it, and presenting their approaches. But still, with the evolving of technology, attacker also was using some AI based tools and methods to breach the security system, and which cost a lot to many people. So, like I'm just quoting one of report here, like that in 2022, $4.35 million um, uh, get cost to the different businesses. This is just a number from one report, but their number will be huge as compared to this. By considering these kind of things, we are proposing the AI based system, which is more efficient and accurate as compared to others previous studies. We propose ensemble D voting classifier, which is a combination of different deep learning models to achieve the significant accuracy. Uh, in literature review, we done an extensive analysis of previous studies and find that what are the gaps or limitation in these studies, and we work on those vulnerabilities and in the previous method, and uh, adopt them to make a more strong and efficient system. Um, we find two main things in previous studies, which we work on that. First is that they use classical machine learning and deep learning methods or techniques in their studies, which are not enough to tackle the new AI-based method and techniques. So we work on this, and we find that there can be use of ensemble learning and transfer learning technique, which can be which can be more useful as compared to classical machine learning and deep learning method, because there is too much diversity in attacks, network attacks, as hacker are using AI based method to control over the other networks. So the single or simple classical or deep learning based model are not enough to detect these kind of attacks. The second thing which we noted that the previous system accuracies is lying between 80% to 97%. So there is still 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 a area to improve that, and we work on this kind of problem. Uh, to overcome this kind of issue, we propose an approach. Uh, which architecture is presented in this diagram. Um, First, we take a network security dataset, which dataset feature representing five kind of network traffic. Four was the network attacks, and one was normal traffic, and that features was different kind of features. Was some was categorical, what some was numerical. So first we done some pre-processing on that data set, and make it more clear for the machine learning model, and convert it into numeric representation. And then we done exploratory data analysis. This data analysis will help us alert that what kind of techniques we should use, and what is the problem in the data set, and what thing we should consider for in our proposed approach. So after that we done data splitting. In data splitting, we split the data set with 80-20 ratio, where 80% data set we use for training, and 20% rest of the 20% we use for testing purpose. So here 80% data we pass for to the models, which are RN, GRU, LSTM, three deep learning models. And these a model will get trained individually on the whole data set. Like 80% data set will go to the RN, and then 80% data set will be used by the GRU, and 80% data set used by the LSTM. After training of each individual model, we pass 20% data to hybrid of these models. Like we combine them under hard voting criteria, and if any sample pass to the this combined model, each model will give a prediction on that data set, and final prediction will be made by that by the majority of vote. Okay, for the target. This is all about our proposed methodology. In proposed methodology, next I am going to talk about dataset description. We use a very famous dataset, which name is NSL KDD. This dataset is available on public data repository. This dataset consists of for attack, DOS attack, R2L attack, probe attack, user to root U to R attacks. In DOS attack, attacker or hacker want to disrupt the services of a system, and in R2L, remote to local attack, attacker using the remote services want to control over a local network. And like we are working a local area network security system. Probe attack, in which attacker and hacker scan the system and gather the information which can use for bad purposes. And the fourth is user to root. In this attacker is basically a user of some system, and he want to control on the administration. So these and fifth type of traffic is the normal traffic. So normal traffic is sample is more in number as compared to attacks. Like those attacks also have some 50,000 plus records, and your to also have some 5,000s, and these also have some 15,000 approximately. But you two are very few in numbers as compared to others. So this data set is highly imbalanced, and which you will see that it will also impact on the performance of the model. So you will see in the result section. So next thing which I'm going to discuss is ensemble decoding classifier EDV. And I define my model with three words: what, why, and how. What means that what is EDVC? The EDVC is a combination of three deep learning model, RNN, GRU, LSTM, which are recurrent applications, recurrent neural network applications. And why means that why we choose only these three models. The reason is that these three model was individually best performer on the used data set. That's we combine them to achieve the significant accuracy. How we combine them? We combine them using a hard voting criteria, which means that each model will give a prediction for attack, and the final prediction will be made by using their vote. Like RNN say, if say that it's a normal traffic, and GRU say it's a DOS attack, and LSTM say it's uh, a normal traffic. So what will be the final prediction? To say that it's a normal prediction traffic, so its final prediction will be a normal, means hard voting we use. And if there is a tie, like first say that it's a normal, second says a dose, but third say it's a probe attack, so we give more priority or more weight to the LSTM, so final prediction will be probe. So this is our criteria to work with the EDVC, in EDVC kind of architecture. We just combine the model prediction using a mode function. So the class with the mode, what will be the final prediction. Next, here in this slide, I discuss about the results. EDVC achieved the significant results because we combine individual significant model, and there was diversity in model output. So you can see the result is ADVC, in which we command 3 deep learning is higher 0.996, but in here you can see we also combine three best machine learning best performers, DTRF and SVM, and the performance is not too good as compared to these. But still here there is some problem with this our study, or there is a limitation, we can say that as the as you to user to uh, user to administration kind of class. uh, you can see here the performance on a model is poor as compared to like other kind of attack, but it's still good as compared to like other simple kind of a model where it's totally poor perform. But we are considering this attack further in our future study to improve it. So here we can see that our model performance is significant as compared to the ensemble of machine learning models. So next, I use a word in my previous slide, diversity. You can see that I say that because there was a diversity in model output. What mean by this diversity? Diversity in ensemble learning refer to difference or variation among the individual model or learner that comprise the ensembles. Means that if there will be more different kind of opinion by each model, there means that there is more diversity, and there are more chances to get a good accuracy. If every model is saying that one thing, then there is no diversity, and we can't say that it's useful in ensemble learning. But if you find a different opinion of each model, then it can be more beneficial in ensemble learning. So we combine GRU. Why we combine GRU or RN and LSTM? We can see here GRU here is poor, and here you can see RN poor, but here this model is good. You can see. So this there is a highly wrong prediction, but this LSTM is very significant here. So these model limitation can be improved by this model. And at this point, this model is poor, and this is good, and this model is also good. At this point, this LST is giving 83 wrong prediction, and here you can see that this model giving zero wrong prediction, this giving zero wrong prediction. So this diversity help us to achieve this significant performance as compared to individual model. If we are going to just using GRU, so is wrong prediction will be wrong prediction. But if we are combining with other models, so they can help this all the things to improve the significant to improve the performance very significantly. Okay, so this diversity matters a lot in our study, so we achieve the significant results. And other thing is that the class distribution in of the NSLKDD, you can see in this diagram, the data set, the data set sample are too scattered, so it's very difficult to find the most optimal weight for one target class. We can't linearly separate this data set, or we can say, so this it's very difficult. You can see that data set is very scattered into two dimensions. So what we can do, so we can't work with the one optimal weights of one model. So we try to adopt multiple models, um, to find their best optimal weight. So these combination of optimal weights can give us a best feature boundaries, or we can say that decision boundaries, to achieve the significant result. So other thing is that the data set is highly imbalanced. This you can see that there is very few regard u to r. So uh, this very rarely you can find here, but so this thing can cause for model overfitting to the majority class. But when we combine three models, so one if one model is going to overfit on this on the training data, then the second model can help to reduce impact of this overfitting. So this ensemble learning also help us to control this overfitting chances. Uh, the In the next discussion, we compare our study with the recent studies, and we can see that there is a use of deep learning and machine learning models. Like in this studies use machine learning, then deep learning and machine learning, and there is a hybrid ensemble model is also used by the some studies. And this study used by two LSTM, but we can't find any ensemble model which are working parallelly. Like most some study also use like this, if we consider this study as two LSTM, but these are combined sequentially. But we in the study we try to adopt these parallelly, and we train individual model and then combine them to achieve the significant results. So these combinations as give us benefit, but still there are some limitation. Like we achieve 99% accuracy for the network detection, and we also prove the significance of our study by using the k-fold cross validation. And it's also the k-fold cross validation results also prove that our study is significant as compared to other. But with this significant, there are also some limitation in this study. One of the limitation is the computational cost, as we are combining training these model individually, and this increase the computational cost. Like our model is taking 1462 minutes in training, like other models are very uh, lower in computational cost. So this is one of the biggest limitation of this study, and which we are considering in our future work to overcome this issue. And the next thing in our study, in limitation which we are considering in our future work, that is the imbalanced data set. And we are going to adopt some data balancing techniques to work on that problem. And for the computational cost, we are going to work on more lighter architecture of deep learning models, to achieve the significant accuracy, but with a low computational cost. So this all about our article. And if you have any question, you can pass it to me, and I will get back to you with the answer. And once again, I would like to thank Medcom chair and organizer for giving us a chance to present our article here. And thank you.